All right, so we are reviewing transformations. Oh, that's the other thing I was going to say. So this is 0.6. If you're keeping up, which you probably aren't because I couldn't even keep up and I messed this up, the 1 point whatevers and the 2 point stuff, that all matches College Board exactly. The 0 points are things I think we need to review or things I want to preload you with. And I was renumbering them from last year. And the last thing we did was 0.4. I intended to make this one 0.5 and I forgot until everything was copied, so I'm just leaving it. So I'm just saying this to say there is no 0.5, and I'm sure at some point somebody might ask or think they missed something. You didn't. He's just not going to exist this year, and maybe I can get my act together next year. Probably not, but we'll try. Okay, so here we are. This doesn't have a place for an ISM page, but this is going on 40, so we can write it right there. This is definitely a review with a twist, meaning you've been transforming things forever. You start to formalize what you're doing in the language in Algebra 1. You do it again in geometry. You do it again in Algebra 2. If you took Algebra 3, you did it again in Algebra 3. We're doing it in pre-cal. You'll talk about transformations. If you take college algebra, you'll talk about transformations in calculus. Like, they're never going away. So there's really nothing new that you haven't learned. But some of the vocabulary is going to be changed just a little bit to match what College Board wants. And maybe the letters you use could be different. It depends. I know I used different letters when I taught pre-AP before it became AP. I'm not sure exactly what all of our teachers on campus do, because when it comes right down to it, it doesn't matter what the letter is. What matters is where the letter is and what it does. So we'll see. Maybe it'll be the same. All right, so transformations, we know, transformations, they affect the appearance of a parent function. We have two basic types. We have rigid transformations. All right, so rigid it's just a change in the position, like you can slide it around, or the orientation if you reflect it, okay? So translations and reflections, flips and shifts, that sort of thing. Then we have non-rigid transformations that distort the shape. That is what you most likely called stretches and compressions, which they still are. We can still talk about them like that. But the word that you will see from College Board is dilations. Okay? And that is a word you definitely used in geometry with this stuff. And that's what it is. It's like when you dilate your eyes, right? And your pupils get huge and they leave them that way. But instead of talking about this is a stretch, this is a compression, just overall it's a dilation, you are not going to have to write out these things like as a free response question on the AP exam. They would be multiple choice. So that's why it's important that we understand the difference in the language so we know what the heck they're talking about. Okay. All right. So it says here are the rules for transformations, and we should memorize them. I'm not a real big fan of the word memorize because to me that's you're just cramming it in your brain so you could regurgitate it at some point. I think you pretty much have most of these down, and so you've learned them. That's more important than memorizing. And then we just need to, like I said, tweak maybe how we write some things. All right, so our translations, we know that's where we shift it up, down, left, and right. So if I'm going to shift it up or down, shift the function up or down, then that is affecting it vertically, which means it would look something like this: f of x minus k, or f of x plus k. What's another way to say f of x? What does it represent? Y. And that's vertical, so it affects the y. So I'm basically taking y minus a number or y plus a number just to take the function and shift it up or down. So I'm going to ask you as we go through these transformations, does this transformation affect x or does it affect y? And I don't know that you've been asked that a whole lot, but that's what's going to help you wrap your mind around all of it. And so if it happens after I do whatever f of x is, like I get my f of x, then I add or subtract something, that's why it's affecting the y, because it's literally affecting f of x. All right, so then if I'm going left and right, that's horizontal, that affects the x. So it would look like this: f of x plus h would be to the left, because remember, x is a liar. And then f of x minus h. Okay. All right, we good with that? But do you see, so this happens like before whatever the function is. It affects x before you actually substitute it in and do whatever you're doing, okay? The k, so h and k could have been what you used last year, could have been something different the year before. C and D is something that I used to use. You can use R and S. It really just depends. But again, all that really matters is it's what is this thing that's being added or subtracted in these places. All right, so then we have reflections. That's the big boy and girl way to say that we're flipping things over. If I have a point right here, we'll call this XY. And then I reflect it in the x-axis, which is a weird way to say it, I know, but that's proper, or across or over, it all means the same thing. So if I reflect it in the x-axis and I get this, which sign changes, the x or the y? The y. The x stays the same, the sign on the y changes, all right? So when you change the sign on y, you reflect in the x-axis. So if I'm going to change the sign on y, it's going to look like this, okay? If I have a point here that we call xy, if I reflect it in the y-axis and it ends up over here, what do I change the sign on? Alanya, where are you? Oh, there you go. Who saved your life? Your mom. So you better be nice to mom today. No teenage attitudes. Okay, just making sure. All right, and then, so when I reflect it, I'm changing the sign on x, right? Which means that this would be f of negative x. Okay? So I change the sign on x, I reflect in y. I change the sign on y, I reflect in x. Everybody good with all that? Okie dokie. So let's talk about our dilations, which are, here are dilations, that's to compress or stretch, which again, it's fine to talk about them like that, but we really just overall call it a dilation, which actually makes it a little bit easier. So vertical dilations, since it's vertical, it affects the y value. So you would have something like a times f of x. And we'd have a times f of x, whether it's a stretch or a compression. What changed, so a is the dilation no matter what. But whether it's a stretch or compression depends on the value of a. If it is a compression, then the absolute value of a is between 0 and 1. Okay? And it's the absolute value because the negative sign would take care of the reflection. So this would be like 1/2, 1/3, 0.5, 0.7, whatever. If it's a vertical stretch, because this is our vertical dilations, this would be the absolute value of a would be greater than 1. Anything greater than 1. So we can say just in general that a function will dilate vertically by a factor of the absolute value of a. Okay. Everybody okay with that? Then we have horizontal dilations, which is going to affect x. So it would look like this, f of b times x. Okay, so it's in there with the x. F of b times x. Now remember, x is a liar. So if it's a compression, which means we would think maybe we'd see a small number like we would here, we don't. The absolute value, oh, I was about to write a. The absolute value of b would be greater than 1. So if that's f of 5x, that's actually a compression. A stretch, the absolute value of b would be between 0 and 1. So since x is a liar, instead of it just, so when it dilates horizontally, it's not by a factor of b, it's by a factor of 1 over the absolute value of b. You just take the reciprocal. Okay. You change the sign on the translations and you take the reciprocal on the dilations. Everybody good with all that? All right, so on the other side, this is just kind of all that same, this function notation column, that's all the same information we just looked at. Then the description has it in words, and then it also has what happens with coordinates, so it's just a different way to kind of put everything together, all right? And if you fold that up like it's going to go in your ISN, that'll fold up where you can see it nicely. Oop, wrong stack. So let me give you your next page of notes. The batteries or the calculators? The calculators just make a stack right here. What'd you do with them?
I put them on the side and I wrote on Signal.
Oh, yeah. No, go ahead and just take them out for me. That way that doesn't get shaken up and then I don't even know what's on the side anymore. There we go. All righty. This is going on page 41 when we're done. All right. Now, the directions say to given each function, identify both the parent function and the transformations from the parent function. So we're going to talk about the parent function. We're not necessarily going to write them all down. But I want you to look at these first 6. The first 5 are actual functions that we could graph because we got absolute value, square root, things like that. Number 6 is in function notation like what we were just looking at, which looks weirder sometimes, but I think is kind of easier than the other ones for y'all sometimes, all right? So when I ask you questions like, does this affect X or does it affect Y, it has to do with whether or not when you're doing your order of operations, you use that number before or after you do the actual function. So like here, this is an absolute value function, right? So inside the absolute value, before I take the absolute value, I'd have to substitute in my X, add 5, multiply by 3, right? So that means the 3 and the 5 affect X. Then I take the absolute value. After I take the absolute value, anything that happens affects the Y value. Does that make sense to you? That's what I mean by affecting X or affecting Y. And if you never truly understand that, then this stuff can be confusing. Once you really get the hang of how you know what's what, this is a piece of cake. Okay, so ask questions if you need to. All right, so let's look at number 1. And we're also going to write these a little bit different from what you have. So just hang on with me right here. So I look at this one. This is a cubic function, right? And so I have x cubed. That means I didn't do anything to x before I cubed it. So there are no transformations that actually affect x. After I cube it, then I subtract 4. That means it affects y. You with me on that? Since it affects y, that means it's vertical. You can abbreviate vertical, vert, that's fine. And this is a vertical translation. Now this is going to differ from how you've written it before probably. What would you normally say? What's happening here? It goes down 4, right? So, but we're not going to write vertical translation down 4. Because I have seen it that way, but more of what I've seen from College Board has said like vertical translation of -4. So it doesn't use the words up and down. It uses a positive number for up, a negative number for down. So it still makes sense, but students were getting tripped up with like if it just said like vertical translation by 3. They're like, which direction? So if it's positive, we're going up. If it's negative, we're going down. Or it might actually say up or down. But we're not going to write in that way because I think if it says that, you're going to get that because that's totally old business. Writing it this way looks a little bit different. But again, you're going to be getting this stuff from multiple choice kinds of questions. So when you read it, you just have to make sense of what they're saying. Okay? And that's the only one I have there, right? We good on that? Okay, so we move on to number 2. We move on to number 2. How many transformations do I have? 3, actually. I have this 2, I have this negative, and then I have this 1, right? Okay, so it's best when you write your transformations down if you do it from left to right. It's not a rule, you don't have to, but when you're trying to match this up with a graph, you need to do your transformations in that order for things to make sense. So we're going to deal with this 2 first. Now, does the 2 affect the x or affect the y? Does it happen before or after we take the square root? And by happen, I don't mean show up. I mean, if I substitute in something for x, I would subtract my 1, make it, change the sign, then I would take the square root, then I would multiply by 2, right? So does the 2 happen before or after the square root? After, when we're talking order of operations. So it's not like the order, it's not on the right of it. So this happens after all of this stuff inside of here happens, which means it affects the y. So this is a vertical what? Okay, so it's a vertical stretch, right? But we're going to write vertical dilation by 2. Okay? So everything outside the square root affects y. Everything inside the square root affects x, which means I have multiplying by this negative. So I know that this is a reflection across. All right, so since that negative sign affects x, what are we reflecting across? Y. Very good. Across the y-axis. Okay? We okay with that? Then I move on to that 1. Does that 1 affect x or y? X. So this is a horizontal, I'm going to abbreviate, translation. Now you can't abbreviate translation because if you abbreviate it trans, it could mean transformation, and it's not specific enough. So horizontal translation of, am I going left or right here? Right, so it would be of 1. Since it's a positive 1, that means you go to the right. Okay. Everybody good so far? All right, good deal. So let's look at number 3. Do you think that negative affects x or affects y? Y, because it happens after we square it, right? So this is that's cubic. It's a quadratic function. So after I square this stuff, then the negative and the 6 would both affect y. So since there's a negative, I know this means there is a reflection across, and which axis would it be? If the negative affects y, we are reflecting across x. Good. All right, we good? The next thing I have is the 1/4. Does that affect x or y? X. So that makes this a horizontal what? Since I'm multiplying. Dilation, good. Horizontal dilation by what, do you think? X is a liar, so it's by what? 4. Good, you take the reciprocal by 4. This 2 is just part of the squared function, so that's not a transformation. Then that 6, does that affect x or y? Y, so this is a vertical translation of 6. Okay, any questions at all? All right, let's look at 4. Do you think that 3 affects x or y? X, because it's inside the absolute value. So this is a horizontal what? Dilation, good. By what? 1/3, good, because x is a liar. Reciprocal, yes. So then that 5, does that affect x or y? X. So this is also horizontal, but this is a horizontal translation of what? -2. Very good. Instead of saying down 2, we're just saying we're translating it a -2. Okay? Everybody all right with that? And to clarify, well, what did I do? Oh, I'm so sorry. I don't know, because my brain, I was jumping ahead in my thought. Yeah, -2, and I'm like, yeah, good. Why is it a 2? It's not a 2. I was looking up there and thinking about something else. It would be -5. I think all I really heard was negative. -5. Okay, this is what I wanted to clarify on. That's why I was looking for it. I was thinking, this is where I wanted to clarify. But all right, so horizontal translation, because this means we go left 5. Now, x is a liar. That's why we know we go to the left. That's why this is a -5. So once the x is a liar in the equation, this is not a liar. which means when you see horizontal translation of -5, that doesn't mean you go to the right. You with me on that? Otherwise you'd be doing it twice. So it's really only a liar like inside the equation. Once we take it out, we write down the truth. Okay? All right. And then the -2 would be a what? Vertical translation of -2. Good. Okay. Everybody good with that? Just gotta go through all of these because other little things happen. We want to make sure that we're looking at this correctly. All right. Does this 1/2 affect X or Y? What do you think? Y. Good, because it happens after we square that. So that means this is a vertical dilation because I'm multiplying by what? Ooh, no. 1/2. Y does not lie because he's a nice guy. Yes. Ah, okay. Y doesn't lie because he's a nice guy. X is the liar. Isn't your ex a liar? I mean, come on. Yeah. Whatever you got to do to remember it. All right. Does this 6 affect X or Y? X. So this is a horizontal, what? Translation. I can't spell. Translation of what? 6. Good, and it's a positive 6. I just got it. Good job, Leo. That's funny. Okay. Are we all good? Okay. Okay, yeah. The square doesn't affect it because that's part of the function. So that's a good question. So the parent function here is y equals x squared. So anything that happens after that is what our transformations are. So since that squared is part of the parent function itself, it's not a transformation. Okay? Good question. Anything else? Okay, good. All right. So then, again, function notation, which I know when you first start having to do these, you're like, these are weird, but I think they're easier. Does this negative affect X or Y? Y. So this is a reflection across what? The x-axis. Good. And then that 4, does it affect X or Y? X. So this is a horizontal what? Dilation by what? 1/4. Good. Does the 3 affect X or Y? Y. So this is a vertical translation of 3. Everybody with me? Yes? All right. So then we have 7 here. That negative does what? Reflection across what? What do you think that negative means I reflect across? X-axis. Good. Is that 4 going to be vertical or horizontal something? Vertical. Good. So this is a vertical what? Dilation by what? 4. Good. Then X is liar, liar. So that 1, that's a horizontal translation of what? -1. Good, because we're going to the left. And then this would be a vertical translation of 2, because it's positive. Everybody with me? Any questions? All right. What does this 5 mean that I do? Or what is it, I guess? a horizontal, what? Translation of 5 by 5, really either way. And then that -1, that is a vertical translation. This one's easy. We probably could have skipped this one, but of -1. Right? All right, I think we can get these last two in here just to get them all done. All right, this negative, does it affect X or Y? X. So this is a reflection across which axis? Y axis. Very good. That 1/3, does it affect X or Y? X. So this is a horizontal dilation by what? 3. Good, because X is a liar. That 4 will be a horizontal translation of what? 4. Good, +4. And then we have vertical translation of what? 7. All right, you got time. You write out 10 while I hand out the assignment, and then I'll come back up here and write it out myself. I think that's 4. Huh? All righty. So that negative is a reflection across which axis? X axis. Very good. That 3/2 is a vertical dilation. Very good. And it would actually be a stretch, not a compression, just because it's a fraction, but a vertical dilation by 3/2. Then I have a horizontal translation of what? -3. Very good. And then I have a vertical translation of what? -8. Very good. All right, so hopefully you can knock this assignment out pretty quickly so we can have all this reviewed so we can move forward with this, because this isn't all we're doing with transformations, but we've got to make sure we're not making up stuff when we're doing this. Okay? Everybody good? What's happening in here tomorrow? Test. Yep, test. So make sure that you come ready for that. You can do well. I know you can.